Welcome back to Talk Tensors. One of the biggest challenges in AI video generation has been like figuring out how to control the movement without having to retrain these massive models every time.
Yeah.
It's like wanting your self-driving car to take a new route, but having to rebuild the entire engine just to update the GPS.
Yeah, it's the
Thankfully, researchers are tackling this head on.
huge problem.
Yeah. And the paper we're diving into today, Training-Free Motion-Guided Video Generation, offers a pretty ingenious solution.
Yeah, it's really exciting work. It's a game changer in terms of efficiency and creative control.
Okay, so let's set the stage a bit. For a long time, we've relied on techniques like generative adversarial networks, or GANs, for video generation.
Right.
Those were like two AIs locked in this constant battle, one trying to create realistic videos, the other trying to spot the fakes. It was a messy but ultimately productive process.
Right, Jane's definitely pushed the field forward. But then came autoregressive models, which generate videos frame by frame, predicting the next one based on the previous ones. Think of it like writing a story where each sentence builds upon the last.
Mhm.
While good at capturing temporal dependencies, these models were like marathon runners, computationally demanding and sometimes struggling to keep up over long distances.
And that brings us to the current rock stars of the AI video generation scene.
Hmm.
Diffusion models. These models work by adding noise to a video until it becomes pure static, and then reversing that process to generate a completely new video.
Right.
It's like taking a perfectly sculpted ice sculpture,
Yeah.
letting it melt into a puddle, and then figuring out how to freeze it back into a brand new sculpture.
That analogy is spot on. And the beauty of diffusion models is that they can produce incredibly detailed and realistic videos. In fact, they've become the foundation for a lot of the groundbreaking work happening today, including the Training-Free Motion Guidance paper we're discussing.
Right.
But before we get into the specifics of their solution, I think it's helpful to understand the problem they're tackling.
You're right, context is key. So what's the main hurdle researchers have been facing when it comes to controlling motion in AI-generated videos?
Well, a lot of existing methods for adding motion require either bulky additional control modules, like clunky add-ons to the core model, or they demand fine-tuning of the entire AI model for each new motion you want to generate.
Okay.
Both of these options are computationally expensive. It's like having to rewire your entire house every time you want to install a new light fixture.
That doesn't sound very efficient, or user-friendly for that matter.
Exactly. That's where the concept of training-free motion guidance comes in. Imagine being able to tell your AI, I want this object to move in a circle, or make this character dance like this without needing to tinker with the underlying code.
Yeah.
That's the dream, and this paper takes a big step towards making it a reality.
All right, so they're essentially giving us the power to direct the AI's movements without having to become AI mechanics ourselves. But how do they actually pull this off?
They've come up with a pretty clever two-part solution. The first part uses a technique called inversion noise initialization. This involves using a reference video to create a specific starting point for the AI's video generation process. If you think of traditional animation, it's kind of like using a rough sketch to guide the final drawing.
So you're giving the AI a starting point, a basic idea of the motion it needs to create. What about the second part?
The second part is where things get really interesting. They introduce something called a frame-to-frame motion consistency loss. Think of it like a feedback mechanism that ensures the generated video stays true to the desired motion path while also maintaining smooth transitions between frames.
Yeah.
No one wants to watch a video that looks like a slideshow on fast forward, right?
Yeah, definitely not. But to really grasp this motion consistency loss, we need to understand how they represent motion patterns in the first place. Do they analyze every single pixel in every frame?
That would be a computational nightmare. Instead, they've come up with a more elegant approach.
Okay.
They focus on a few key points in the video,
Okay.
which could be the center of a moving object, points manually selected by the user, or even points automatically identified by the system itself.
Okay, so they're simplifying things by zeroing in on the most important parts of the motion. What do they do with those key points?
They analyze the correlation patterns of these points across multiple frames. Imagine you're tracing the path of a dancer's hand as they move across the stage. You'd essentially be capturing the essence of their movements, how their hand relates to their body and the surrounding space over time.
Right.
These correlation patterns essentially form a blueprint for the desired motion, which the AI then uses as a guide during video generation.
That's a great way to visualize it. It sounds like this approach is all about finding that sweet spot between efficiency and accuracy. But does it actually work? I mean, can they really generate high-quality videos with smooth, realistic motion using this training-free method?
The results are pretty impressive. In fact, they actually put their method to the test using a variety of benchmarks and data sets, including ones specifically designed for video editing and dynamic action sequences. And guess what?
What?
Their method not only excels at following the desired motion path, but it also consistently produces smooth transitions between frames.
That's encouraging to hear. But did they compare their method to other approaches? It's one thing to say it works, but it's another to show that it outperforms existing techniques.
They did, and the results are quite compelling. They compared their training-free approach to a state-of-the-art training-based method called Motion Director.
Okay.
And in a user study, people actually preferred the videos generated by the training-free method.
Wow. That's quite a testament to the quality and realism they're able to achieve. This feels like a major leap forward in terms of making AI video generation more accessible and user-friendly. But before we get too carried away celebrating, I'm curious about something. They mentioned being able to simulate animal movements using hand gestures. How exactly does that work?
That's one of the most fascinating aspects of this research. They used a simple phone camera to capture hand movements,
Okay.
and then use that data to guide the motion of a rabbit's ears and a snake's body in a generated video.
Wow.
It's like a digital puppet show with hand gestures becoming the strings that control the AI-generated characters.
That's incredible. I can already imagine the potential applications for this kind of technology in animation, filmmaking, and even interactive gaming. It opens up a whole new realm of possibilities for creative expression.
It truly does. And speaking of possibilities, I think it's time to shift gears and venture into the realm of speculation with our Novel Notions segment.
You're right. Let's dive into those mind-bending what-ifs and explore the potential future this research might unlock.
So before we went on that tangent about AI puppeteering, we were talking about the potential of this technology to make video creation more accessible. I think that's where this research could really make waves.
You're right. The democratization aspect is huge.
Yeah.
Right now, creating professional quality videos often requires expensive software, specialized equipment, and a whole lot of technical know-how.
It's a barrier to entry for so many people, but imagine a world where anyone with a smartphone and an internet connection could create compelling videos regardless of their technical expertise. This training-free approach could be a game changer, empowering individuals, educators, small businesses, you name it.
It's like the difference between needing a professional recording studio and being able to produce music with just a laptop and some basic software.
Exactly. It levels the playing field and opens up a whole new world of creative possibilities. Speaking of which, I'm particularly excited about the potential for education.
Yeah.
Imagine teachers being able to create interactive video lessons with custom animations and simulations tailored to their students' needs.
That would make learning so much more engaging and effective. And think about the potential for students to create their own animated presentations or even short films. It could completely transform how we approach storytelling and knowledge sharing in the classroom.
Absolutely.
Yeah.
And it's not just limited to education. Healthcare, architecture, social media, almost any field you can think of could benefit from this technology. Imagine doctors using AI-generated videos to explain complex medical procedures to patients, or architects creating virtual walkthroughs of buildings before they're even built.
The possibilities are pretty mind-boggling. But as with any powerful technology, we have to consider the potential downsides as well. One thing that immediately comes to mind is the potential for misuse, especially when it comes to creating deepfakes.
You're right, that's a valid concern. Deepfakes are already a serious issue, and this technology could make it even easier to create realistic-looking videos of people saying and doing things they never actually did. That could have a significant impact on everything from political discourse to personal reputations.
It underscores the importance of developing safeguards and ethical guidelines alongside these technological advancements. Perhaps we need to explore techniques for watermarking or identifying AI-generated videos, or even develop new tools specifically designed to detect deepfakes.
I think education is crucial as well. We need to make people aware of the potential dangers of deepfakes and equip them with the critical thinking skills to discern real videos from fake ones. It's about fostering media literacy in a world where the line between reality and fabrication is becoming increasingly blurred.
Another concern is the potential impact on jobs in the creative industries. If anyone can create professional-looking videos with ease, what happens to the video editors, animators, and filmmakers who have spent years honing their craft?
That's a complex question, and there's no easy answer. But I think it's important to remember that AI is a tool, not a replacement for human creativity and expertise.
Yeah.
It's like the invention of the camera. It didn't eliminate the need for painters, but it did change the way we create and consume art.
It's about finding ways for humans and AI to work together, leveraging each other's strengths.
Exactly. Perhaps we'll see the emergence of new hybrid roles, where human creators act as directors or curators, guiding the AI and refining its outputs to achieve a specific artistic vision.
I can see that happening. Instead of replacing jobs, it could lead to new and exciting collaborative workflows.
And who knows, maybe we'll even see new art forms emerge, ones that seamlessly blend the organic imperfections of human expression with the precision and capabilities of AI generation.
I'm curious to see how this technology might influence the evolution of video as a medium itself. What happens when video editing becomes as intuitive as editing text? Will we see a shift towards shorter, more personalized video content, or perhaps a move towards more immersive and interactive video experiences?
Those are great questions. It's fascinating to think about how these advancements might not just change how we create videos, but also how we consume and experience them.
This deep dive is really making me question everything I thought I knew about the future of video. But before we get too lost in the big picture, let's zoom back in on the paper itself. I'm still curious about some of the technical details behind their approach.
Sure, what are you thinking of?
Well, we talked about how they analyze these feature correlation patterns to capture the essence of the motion. But how do they actually implement that in practice? What does that process look like?
Good question. They actually define a specific loss function that measures how well the generated video aligns with those desired motion patterns. You can think of it as a feedback mechanism that tells the AI how well it's doing in recreating the target movements.
So the lower the score on the loss function, the closer the AI is to nailing the desired motion.
Exactly. And by minimizing this loss function during the video generation process, they ensure that the output video adheres to the motion blueprint.
That makes sense. They're essentially giving the AI a goal to strive for and then rewarding it for getting closer to that goal.
Precisely. They also utilize a technique called classifier guidance, which helps nudge the AI in the right direction during generation.
So it's like having a coach on the sidelines, whispering tips and suggestions to the AI as it's creating the video.
That's a great analogy. And it's the combination of all these techniques, the clever motion representation, the loss function, and the classifier guidance that allows them to achieve such remarkable results.
It's really impressive how they've managed to solve a complex problem with a surprisingly elegant and efficient solution. And that simplicity is key when it comes to making this technology accessible to a wider audience.
I completely agree. It's a testament to the power of innovative thinking and the potential for seemingly small breakthroughs to have a ripple effect across entire industries.
This paper has given us a lot to ponder. But before we wrap up, I think it's time to revisit our novel notions segment and explore some even more mind-bending possibilities. What if we could go beyond hand gestures and control AI-generated videos with our thoughts?
Now you're talking. Brain-computer interfaces are still in their early stages, but the potential is definitely there. Imagine being able to create entire worlds and stories just by imagining them.
We could literally bring our wildest dreams to life on screen. Thought-controlled videos, that's a novel notion that really captures the imagination. It's like something straight out of science fiction, but with this research, it feels like we're inching closer to that reality.
It's definitely a tantalizing possibility, but even without venturing into the realm of brain-computer interfaces, there are so many other exciting avenues to explore. What if we could generate videos based purely on natural language descriptions?
Yeah.
Imagine typing something like, "Show me a video of a robot dog learning to skateboard in a bustling city park," and having the AI create a compelling and humorous short film right before your eyes.
That would be incredible. We've already seen the power of text-to-image generation with models like DLE and Stable Diffusion.
Yeah.
It seems like the next logical step would be to extend that capability to video.
It's a natural progression. And it wouldn't just be about generating the visuals either.
Right.
Imagine being able to specify the mood, the pacing, the camera angles, all through natural language. You could essentially direct an entire film just by typing.
It would be like having a virtual film crew at your fingertips, ready to translate your words into a cinematic masterpiece. That could truly democratize filmmaking and storytelling, empowering anyone with an idea to bring it to life on screen.
Absolutely. And it wouldn't have to be limited to just realistic videos either.
Yeah.
What if we could use this technology to create entirely new forms of visual expression, blurring the lines between reality and imagination?
Now you're speaking my language.
Yeah.
I'm picturing abstract art in motion where shapes, colors, and textures flow and morph in mesmerizing ways.
Oh, yeah, that's cool.
Or imagine generating videos that explore impossible geometries and physics-defying movements, creating a visual language we've never seen before.
It would be like opening a portal to a new dimension of artistic expression.
Yeah.
And we could even push the boundaries further by creating interactive video experiences where the viewer's choices influence the narrative, leading to endless branching storylines.
It's like those choose-your-own-adventure books we loved as kids, but on a whole other level of immersive storytelling.
Yeah.
The viewer becomes an active participant, shaping the narrative as they go.
Exactly. It would be a completely new way to experience video, blurring the lines between passive consumption and active creation.
All these novel notions have really stretched our imaginations today. It's inspiring to think about the potential this research unlocks and the future it hints at.
It's clear that we're on the cusp of a major transformation in the world of video creation. The possibilities are truly limitless, and I, for one, can't wait to see where this journey takes us.
This deep dive has been a wild ride. We've explored everything from the technical nuts and bolts of training-free motion guidance to the mind-blowing implications for the future of video. It's a lot to process, but we hope you've enjoyed exploring these ideas with us.
As always, we encourage you to check out the paper for yourselves. The link is in the show notes.
And in the meantime, keep those novel notions flowing. The future of video is waiting to be shaped by our collective imagination.
From all of us here at Talk Tensors, thanks for listening.